What's up, guys? So we are start from our GRE Math subject 9376 form. So in this video we solve 20. I plan to solve 28, 29, and 30. Okay, so 28 say that A B be a vector subspace and must be a subspace which will follow. This is the old school problem. So all you need to remember is A plus B is subspace and A intersection B is subspace. Okay, so the first one is A plus B. This is a subspace. Okay, so maybe let me remind you that how to check this is a subspace. To check W belongs to V is a subspace. You need the first is closure. So closure means that A be in W, then A plus B must be W. The second is if A is in W, then any if you take any scalar K, so if field is K, K means in the GRE case we only talk about RC, right? So any K times A must be W. So we need to check if these two are satisfied, then this is a vector subspace. If not, this is not a vector subspace. Okay, so the first one, A plus B is A plus B, so A is A, B is B. So the closure is simple, right? So let me remind you why. Suppose A1 belong here, A2 belong here, then A1 has some factorization of A1 prime and B1 prime, and A2 has factorization of A2 prime and B2 prime. A1 prime is in A, B1 prime is in B, A2 prime is in A, B2 prime is in B. So A1 plus A2, just A1 prime, A2 prime, B1 prime, B2 prime. And A is a subspace. So A1 prime, A2 prime is in A, B1 prime plus B2 prime is in B. So A1 plus A2 is in A plus B. Right, simple. And when you times the scalar, the argument is exactly the same. So A is definitely a vector space. B. So this is famous result that you should remember, because in a test that you don't have enough time. So A union B, if you give me two vector spaces, do the union. Usually this is not a vector space. Usually, okay. So it's not. How do I prove this? Since we guess it's not, right? So we don't need anything. We just need to find a counterexample. Suppose in 3 dimension, I let A to be xz plane, xy plane. So xy plane means the z equals to 0. So the point in A just xy 0, and xy can be all the real numbers. And the B I choose xz. So basically it's similar, but y is 0. So when A intersection B, you have these two. But it's very likely that you can take two vectors and add them, then it gives you some vector which is not in an intersection. So for example, I can take 1 1 0 in A plus 1 0 1 in B. So this gives me 2 1 1. 2 1 1 is definitely not in A union B, because in A union B, either Z component or either Z component or the Y component need to be 0. But in this case, three of components are non-zero, so not in A union B. So this is not a vector space. Okay, and third is important that you should remember the result. So A intersection B is a vector space, and I only prove one example. Suppose I only prove suppose you have two vector A1 and A2 in A union B, and I in A intersection B, and I want to prove that A1 plus A2 is in A intersection B. So proof. So when A1 in A intersection B, that means A1 in A and A1 belongs to B, and A2 belongs to A and A2 belongs to B. So this tells you that since A is a vector space, so A1 A2 belongs to A and A1 A2 belongs to B. So combine these two, combine this fact that we know A1 plus A2 belongs to A intersection B. So the number 3 are vector space. The number 4 is tricky. Or maybe if this is the first time you see a number 4, you may need to think carefully. But it's not difficult. Okay, so number 4 is that if somebody give you a vector space, and I collect all the points which is not in that vector space, is that a vector space? Okay, so the answer is definitely not, because a vector space need to have an identity element. So if zero vector in A, then since A is a vector space, so zero vector must be in A. Then zero vector cannot in X belongs to V, X not A, not belong to A, right? Because every vector space intersection must have one vector called zero vector, but A already took out the zero vector, so there's no way that the complement of A can take the zero vector. Then this proves that the number 4 is not the vector space. So the answer is number 1 and number 3. So what we need to is B. Okay, and I think this video is too long, so I will separate into next. And be sure to subscribe to my channel, and hope to see you guys in the next video.